Alright, this video we're going to describe 3 ways that you can use to prove that two triangles are congruent or are the same triangle, right? So there's going to be 3 basic ways. There are really more than that. We're going to focus on these 3 ways, and really after today we're mostly going to focus just on the last 2 here that we talk about. So let's get going here. One way that we can prove that two triangles are the same or that they're congruent is if we can prove that each side is congruent to the corresponding sides on the other triangle. So if we can prove that 3 of these sides on this triangle are the same as 3 corresponding sides on this triangle, then we can say the two triangles are congruent. So really we're just saying if 3 sides are congruent to 3 corresponding sides. Remember, we're always talking about corresponding. Then we're allowed to say that the two triangles are congruent. So if 3 sides are congruent to 3 corresponding sides on the other triangle, then the triangles are congruent. I'm not going to write all that because I can just say it. So for example, if in this triangle we measure that those 2 sides are the same length, if we measure that these are the same length, then we give them these hash marks. I'll talk about that in a sec. And if we measure that this side is congruent to that corresponding side, then we've said that 3 sides on this triangle are congruent to 3 corresponding sides on this triangle, and we can say the two triangles are congruent. We'll get to that in a sec. To say that sides or segments of a triangle are congruent, we use these little hash marks here. And you get a tally mark or hash mark starting with 1. Then if you measure a second side, you put 2 marks, and you keep going for how many sides. In triangles, we'll only do with 3 sides, 3 different sides. If all of these sides were the same length, they would all just get 1 mark, and the corresponding sides would all get 1 mark. But each of these legs or sides of the triangle are all a different length, so they all get a different hash mark, a different number of hash marks, and the corresponding sides get the matching number of hash marks. Alright, so hopefully that's clear. Remember in our last lesson we talked about how to name congruent triangles, so let's see if we remember how to do that. That's an X right there. So if we prove that these two triangles are congruent, well then we can name or state that they're congruent using what's called a congruency statement. It's basically saying that this triangle is congruent to this triangle. And when we name them, their corresponding parts have to match up. They have to be in the same order. So if we call this first one triangle ABC, really it doesn't matter what you call that first one, what order you put these letters in, as long as the second triangle that you name has its corresponding parts in the same order. So we have to say what's corresponding with A, because that's the first thing we have to put in the other triangle's name. Well, A was corresponding with X, so X comes first over here. B is corresponding with Y, so Y has to be the second one in this name. And the last one, C and Z, are corresponding, so C and Z have to be the last letters in their names. So we just made sure that when we named the corresponding triangles, their names, the letters in the names corresponded and were in the same order. So hopefully you remember that from last lesson. Let's do one more here. So as you can see, these triangles aren't quite as obvious that they're the same, although it's still fairly easy. Say that this one is the same as this one. Again, hash marked for segments. This one is corresponding and congruent with that side. And this side is corresponding and congruent with that side. So again, we named 3 sides that were congruent. We used our side, side, side proof. Again, if we call this, let's say M, N, O, this is an N up here. And we call this one, let's say L, K, and H. Doesn't really matter what we name these here. Then whatever we name this first triangle, its corresponding parts in this triangle need to match up in the name. So if we name this one, let's get crazy here, let's call it O-N-M, using the 3 letters in the name, the 3 vertices. So make sure that you line up corresponding parts on this one. So what's corresponding with O? Well, L is. So L's got to go first. What's corresponding with N? K. So K's got to come next. And what's corresponding with M? H. So when we name congruent triangles, we make sure their names are corresponding in the same order. And that's side, side, side proof. That's our first proof. Let's talk about our second proof. This is called side angle. That's what the A stands for, side. And here, if two sides and an angle in between. So as long as there's an angle in between two sides, if those are congruent with corresponding parts of the other triangle, then the two triangles are congruent. So this side has to be congruent with another side. This angle has to be congruent with its corresponding angle in the second triangle. And the side, the last side, has to be congruent with its corresponding side. If we can prove those three things, then we can say they're congruent. So we'll get to that in a sec. So for example, this is what side angle side will look like. Let's say that these two segments or sides are congruent. And let's say that these two segments or sides are congruent. Well, let's look back at our proof here. It needs to be the angle in between the two sides. So it can't be this angle. It can't be this angle. It has to be the one that's in between the two sides. If that's true, and its corresponding part over here is also congruent, then we can say the two triangles are congruent using side angle side as our proof. So let's see if we can name them here. Again, we'll start easy, A, B, C. Let's use M, N, and O on this one. So if we name this first triangle ABC, well, we just have to make sure that the corresponding parts in the second name match up. So what's corresponding with A? Well, whatever had the arc, M. What's corresponding with B? N. And what's corresponding with C? O. So as you can see that the names don't have to match up with the type of proof we're doing. I don't have to name it side, so B, A, C. I don't have to name it in that same order. So the names of the congruent triangles don't necessarily have to match up with the proofs. But the proofs do need to be true. And they also need to be in this order. It needs to go side, angle, side. And those parts need to be right next to each other. So we can't skip a side, we can't skip an angle. If that happens, it's not a proof. We can't use it. They all have to be right next to each other. So this side is right next to this angle, which is right next to the last side in our proof. All right. Let's do one more side angle side here. Let's say that this side right here and this side are congruent. Let's say that this one and this one are congruent. Then what angle do we have to be talking about? We have to be talking about the angle that's in between the two sides. So if I go to the left here, I'm saying side, angle. Well, I haven't talked about this side, so I can't go that direction. I got to go this direction, to the right. Side, angle, side. There we go. Now they're all right next to each other. I go in that order, side, angle, side, and I'm not skipping anything. So over here, same thing. Side, angle, side. That's what we got to do. And, oh, I forgot to talk about it. Angle, congruent angles, or their corresponding congruent angles, they get what's called this arc. It's like a little rainbow in the corner of the angle. So the corresponding angles that are congruent get the same amount of arcs, similar to how sides or segments got the same number of hash marks. And we'll do an example of that in a sec here. Let's finish this off. Let's say that this is J, K, and L. Let's call this one R, S, T. So it doesn't matter what order we say the first name in. Let's just go what it looks like, J, K, L. Doesn't matter. But the second name is what matters. It needs to be corresponding. So what's corresponding with J? Well, I believe that T is corresponding over here. It's basically the one that's opposite the angle right here. So that's T. What's corresponding with K? Well, it's the angle that gets the arc. So what got the arc in this triangle? R. And the last one, L, was corresponding with L. That must be S, right? So that's how we have to name it if we name it triangle JKL here. Its corresponding congruent triangle has to be triangle TRS. So that is side, angle, side. Let's see what this one is. Hopefully you can figure out what this means. It's angle, side, angle. And hopefully you have an idea of what the definition of that is. If two angles and the side in between, so as long as there's a side in between two angles, side in between are congruent to the corresponding parts of the other triangle, right? To the corresponding parts. Then we can say that the triangles are congruent. That's a 2 right there, TO. So let's see what that looks like. If we got this angle congruent to this angle, they get one arc. Let's talk about another angle. So if we're talking about a different angle, we increase the arcs. So this one gets 2 arcs. And if we were to talk about this third angle, it would get 3 arcs if it was a different measurement than the other two. So we're using angle, side, angle, so we're looking for the side that's in between the two angles. Well, it must be this side. That's the side that's in between the two angles. And again, angle, side, angle, they all have to be right next to each other. We can't skip any side or any angle. And if we name this ABC and this XYZ, we can name the corresponding congruent triangles. Call it triangle ABC. And we have to just line up the corresponding parts. A and X are corresponding, B and Y, and C and Z. Okay, let's do one a little bit trickier here. Let's talk about this angle and this angle. And let's talk about this angle and this angle. So what side do we need to refer to if we're going to use angle, side, angle proof? It's got to be the one in between the two angles, so this one. Okay, if we name them M, N, and O, and R, S, T, let's try and name these corresponding congruent triangles. Let's call the first one M, N, O. What's corresponding with M? It's whatever has the first arc over here. Well, T does. It's corresponding with N, whatever has 2 arcs, S. And the last one, corresponding with O, is R. Okay, so hopefully you're getting this. That's our 3 proofs. The one last thing I want to emphasize here, and we'll get into this a whole lot more, is corresponding parts of congruent triangles are congruent. So if we can prove that 2 triangles are congruent, like we did here, we just happen to use angle, side, angle in this proof, then any of their corresponding parts, doesn't matter if they're segments or angles, any of their corresponding parts are also congruent. So whether we talked about them in our proof or not, they're always going to be congruent as long as they're corresponding and as long as we prove that the 2 triangles are in fact congruent. We'll use this as a reason for our proof a little bit later on in the next video. So those are the 3 proofs. Let's try and do a proof real quick. So here we got 2 triangles. We're given a statement. We always start with our given statement. So just rewrite it. E is the midpoint of MJ. We may have to continue this video in a second. I'm running out of time. And that's always given. Ask yourself one question after you write the given. What does that allow you to draw in the picture? If E is the endpoint of MJ, well, we know these segments have to be the same length. Segment ME is congruent to corresponding. So what's corresponding with M? J is, so J has to be named first with segment JE. And that's really just the definition of a midpoint. Okay, definition of a midpoint. So write your given statement, ask what does that allow you to draw, and then talk about what you just drew. Let's repeat the process. Let's use the next given statement, TE. That's, perpendicular with MJ. And that's given. What does that allow us to draw in the picture? If this is perpendicular to this, then we know we got 2 90-degree angles. So what did we just draw? We drew angle MET is congruent with angle JET.